Hi there, this is Math 148, section 14.2, partial derivatives, or actually in this problem we're doing partial second derivatives. So here's the question. Number 29, if z equals x squared y minus 4y, I think this is y squared. Let's see if I can do this squared. There. Find zxx, zyy, zxy, zyx. Oh my goodness. So this whole alphabet soup, the challenging thing about it is trying to figure out what the notation means and then being careful about how you do this. So each one of these, zxx, I've done it down here for you. Here's the notation. This first variable here means the first derivative, and the second one to the right means the second derivative. So zxx, you would say that the second derivative in terms of x, and this is another way they sometimes write it. This is in second derivative in terms of x. Okay, zyy means you take the first derivative in terms of y, and then you take the second derivative in terms of y. So it's zyy, the second derivative in terms of y. And this is the same notation, just a little bit different way to write it. And now look at this one, zxy. That means you do the first derivative in terms of x, and then you take the second derivative in terms of y. And then it looks like this. The second derivative, first in terms of x and then in terms of y. And now you see the pattern. zyx means you take the first derivative in terms of y and then the second derivative in terms of x. So, question number 29. Here's the first, go back to the top. Here it is. This function, zxx. Let's do it. Oh, that's the function. I forgot I've got this. So this is what that function actually looks like. You can see this is the x-axis, and this is the y-axis, and that's z. So you have this kind of curving, saddle-y shaped surface. So we're going to find the rate of change in terms of x and y, and that's what the derivatives represent. So question 29. I think of these as a little bit like a game of Twister, in that it's not that it's so complicated. You have to just pay attention to what your left hand is doing and what your right hand is doing and make sure you know where you are. Okay, maybe it's a little harder than a game of Twister. So part A, zxx. So you'll notice there's 2 here. So we have to do 2 in second derivatives. So we're going to do this twice. One thing I like to do for these is I like to circle the variable that I'm taking the derivative of. It just keeps my life simple. So the first one, I'm doing the first derivative. Let's do it like this. The first derivative of z in terms of x, z with a little x at the bottom, we're going to take the derivative of this function. So the derivative of this piece, x is our variable, that's 2x, and then y is a constant, so I just write it, just y, that's easy, just comes along for the ride. And the derivative of this piece is minus 4. X is the variable, so the derivative of x is 1, and y is a constant, so it's 4y squared. That's just the first derivative, right? We want the second derivative. So we do it again. Wasn't that hard? We do it again. Now the left hand. Again, we were taking the derivative, this one, in terms of x, so I'm going to circle the x's. Ah, there's no x. That's okay. We can keep going. So the derivative in terms of x, this piece, that becomes 2, the derivative of x is 1, and then y is a constant, minus this whole piece is a constant because I'm treating y like a constant. So it could be a number or pi, or although pi is a number, so the derivative of a constant is 0. So this whole piece is 2y. So we are 1/4 of the way through our problem. zxx is equal to 2y. And you can see that is why I cross my z's, because my z's look like 2's. It's one of my great personality flaws. Okay, white. Here's part B. Come on, baby. Part B. Find z, y. Is part B zyy or zyx? Ah, I got that wrong. Part B is zxy. Haha. Okay. So we take the first derivative in terms of x and the second derivative in terms of y. Well, the first derivative, see, that's first derivative in terms of x, second derivative in terms of y. So the first derivative in terms of x, well, we just got that in the previous problem, which is probably why they have these problems stacked this way. The first derivative in terms of x is 2xy minus 4y squared. And you can rewind the video if you want to see that first derivative of x again. But that's, again, 2y. Sorry, hold on. I'm sorry, guys, I had to go back and look at it. This is the first derivative in terms of x. In terms of x is minus 2xy minus 4y squared. So now we want to take the second derivative in terms of y. So I'm going to circle y because y is our variable. Why am I circling it? Because y is the variable. So now we're taking the second derivative, so the derivative of the first derivative, second derivative, in terms of y. So this is our variable, I on this yellow thing. So the 2x, that's a constant. We can just leave it out in front. The derivative of y is 1, because the derivative of y is 1, minus 4. The derivative of y squared is 2 times y. So this whole piece looks like 2x minus 8y. 2x minus 8y, and that is equal to the derivative in terms of x, and then the second derivative in terms of y. So the first derivative in terms of x, and the second derivative in terms of y. So you can see where the challenge here is in keeping your notation and what you're doing straight. So here's the function again. I'm rewriting it just so I have it for reference. 4xy squared. Okay, part C. Halfway through, you guys, we can do it. So part C says zyx. I think I have my other parts all messed up, so just ignore that. zyx. So this means first derivative in terms of y, first in terms of y, and the second in terms of x, because you kind of read them left to right, in terms of x. So let's take the first derivative in terms of y. So we're taking the derivative of this function, and now we're using y is our variable. So I'm circling y. So it's going to be x squared is a constant, and then the derivative of y is 1, so that whole piece goes to there, minus this whole piece, 4x is a constant, and the derivative of y squared is 2y. So the first derivative in terms of y is x squared minus 8xy. This is a bit tedious to just sit and watch, so you might want to do this one on paper with me and see. I bet you're faster. I bet you're faster than I am. So now we want to take, so we just have zy. We want zyx. So now we take the second derivative in terms of x. And this is why I like to circle the variables. So now I'm thinking x is the variable. Okay, so I think the derivative of this is 2x. The derivative of x squared, 2x, minus, okay, I have 8. Y is a constant, because I'm doing it in terms of x. And now the derivative of x is just 1. So the answer is the derivative of z, first derivative in terms of y, second in terms of x, is equal to 2x minus 8y. Left hand blue, right foot green. That was a twister reference. Okay, last one, you guys. We can do it. Question number 29. I'm writing it here as a reference. You can see that each problem, because you had to take 4 second partial derivatives, it's essentially taking 8 derivatives. Let's be honest, you're taking a derivative 8 times. No getting around it. Okay, unless you don't do your homework. But you're going to want to. You're going to want to have practice with this. Finally, z, y, y. So the second derivative in terms of y. So just taking the derivative in terms of y twice. So first, let's take the first derivative in terms of y. So this is our variable. Y is the variable. So this equals x squared is a constant. Derivative of y is 1. So that's this piece. Minus 4. X is a constant. Derivative of y squared is 2y. So this whole thing equals x squared minus 8xy. We did that in the previous problem, but I just redid it for you. So that's the first derivative. Right? First derivative. We want the second derivative, so we take zy, y. Okay, and again I like to circle the variable, just, oops, red, circle, that's the variable. Ah, there's no y here. So the derivative of this piece, we're doing it in terms of y, and there's no y component, so that is 0. And this one, 8x is a constant, so we can write 8x, and the derivative of y is 1. So the answer here is z, second derivative of z in terms of y is negative 8x. Whew! So definitely work some of these and get in the practice of finding a way for you to consistently keep your notation straight and make sure you're taking the right derivatives in the correct order, and that will help you out. The applications are in section 14.3, and in section 14.4 we use these second derivatives to find the various cool, rates of change. Again, this is x-axis, this is y-axis, and this is z. And there's our pretty little function that we spent so long looking at. All right.